Hey guys, Andre Freeman here. All right, let's look at an example involving a hypothesis test for a population proportion. This is discussed in units 3.3, 3.4, and 3.5. So you really want to make sure you understand this concept well before taking the Module 3 quiz and moving on to Module 4. Basically, there's information about a sample, and we're going to use that information to test a claim about a population proportion. So let's take a look at this example. So it says a 2019 Pew Research poll found that 68% of US adults believe that fake news, made up news and information, is detrimental to the US democracy. A researcher surveyed 180 college students in Connecticut and found that 110 of them believe that fake news is detrimental to the US democracy. Does this sample provide evidence that the proportion of college students in Connecticut who believe that fake news is detrimental to the US democracy is less than the national rate? Use a level of significance of 5% to test this claim. So the research question, which is identified here, is focusing on the population of college students in Connecticut. So we really want to understand that the proportion of college students in Connecticut who believe that that fake news is detrimental, this is basically the population proportion of interest. So as we get to part A, I want to just do some labeling first. So P, this is going to be the population proportion of, it's a population proportion. And this is, let's write it as the proportion, right, which is really like saying the percentage. The proportion of Connecticut college students who think fake news is a problem. Proportion of Connecticut college students who believe fake news is a problem for the United States democracy. Okay, so this is the unknown population proportion. Again, this is unknown, right? We don't know the percentage of all Connecticut college students who believe that fake news is a problem for our democracy, right? We don't know that proportion. We don't know that percentage. It's unknown. But we have information about a sample, and we also are going to compare that in a way to what we know about the national rate. Okay, so to wrap this up, this is what we're defining as P. All right, so let's get to part A. So the first thing that we should do here is recognize that there is, the national rate is a 68% figure, right? Because in 2019, a study found that 68% of adults believe fake news is a problem. So this is essentially what we're thinking of as the national rate. And the research question is asking whether or not the proportion of college students in Connecticut who hold this view is less than the national rate. Okay, so this is what we need for our hypotheses. So for part A, the null hypothesis will basically assume that the population proportion is equivalent to the national rate of 68%. And the alternative hypothesis is based on the research question or claim. Well, in this case, we're saying less than, right? Does the sample show that the population proportion is less than the national rate? So the alternative is based on the research question or the claim. So we'll have a less than here. So we have a left tilt test, right? This is critically important. Once you determine your alternative, you know the type of test. We'll do a left tilt test. And this is going to specify how we compute the p-value. So the second question about the normality criteria. So the normality criteria, we need two things. We need that the sample size times the assumed population proportion and the sample size times 1 minus the assumed population proportion. They both must be at least 10. And this basically ensures that the sampling distribution of sample proportions, which we're using, will be approximately normal, so we can use the normal distribution to compute a p-value and come up with a decision. Okay, let's write down some information. The sample size here from the sample is 180 college students. And we know that X, the number of them who said, yes, they believe fake news is the problem, is 110. P is the assumption from the null hypothesis, which is 0.68. So we're going to use N and P for this next part here. N is 180 and P is 0.68. Let's see what that equals. That will give us, and we can do this in decimals, but let's do this here. This is going to give us 74.8. So that condition is met. Now let's do N times 1 minus P. N is 180, and 1 minus P is still 0.68. This simplifies to 180 times 0.32. And that's going to give us 57.6. So this is also, both of these conditions are met. So we can proceed with the hypothesis test. So the conditions are that the sample size, N, times the assumed population proportion, and sample size times the complement of that, 1 minus P. Both of those products have to be at least 10. The standardized test statistic, this is basically the z-score of the sample proportion, assuming the null hypothesis is true. Okay, so let's look at the formula, and we'll do this in Desmos. Okay, so we have z equals, it's going to be the sample proportion minus the assumed population proportion divided by the standard error, which is the assumed population proportion times 1 minus P. So you've used this in module 3, divided by N. This is basically a z-score of the sample proportion. So let's write that down. Z-score of sample proportion, assuming the null hypothesis is true. And let's talk about that in a second. So assuming that the null hypothesis is true. So if we assume that the population proportion is 68%, we're going to find the z-score of the observed sample proportion, which we haven't found yet, but we can find right now. Let's do that. So let's find the sample proportion, right? What is the proportion of the sample of students, Connecticut college students who hold this view? So the sample proportion, that's P hat, right? This would be P hat, and this is going to be X divided by N. Basically the number of successes in the sample divided by the sample size. So when you do 110 divided by 180, you get 0.61. And you can round that to, we can just round to 2 decimal places, so 0.61. So assuming the population proportion is 68%, let's find the z-score of the sample proportion of 61%. All right, let's do it, and then we'll do the rest of this in Desmos. So z is going to be 0.61 minus 0.68 divided by square root of 0.68. 1 minus P, we did that up here already, right? The 1 minus P simplified to 0.32. So this is going to be 0.32 here. And we're dividing that by the sample size, which is 180. So make sure this makes sense. Square root P is 0.68. 1 minus P is 0.32, N is 180. So we can do this in Desmos, and we can also find the p-value in Desmos. So we just saw it was parentheses 0.61 minus 0.68 divided by square root. You can do SQRT. Oops, don't do it with capital letters. SQRT, and it converts to a square root sign. And here we're going to do, let's make this a little bit bigger. We're going to do now let's see, parentheses, 0.68, that's P, 0.32, that's 1 minus P divided by N, which is 180. Okay, so this is the z-score of the sample proportion 0.61, assuming the population proportion is 0.68. Remember, that's an assumption. We don't know what the population proportion is, but we're going to assume it's 0.68 so we can perform this test. So this is the left tail test. So because this is the left tail test, we need to now find the area to the left of this z-score. To do that, we can enter in the normal distribution command, normal dist. We'll do 0, 1. Remember, always click on the magnifying glass. It gives you a nice image here. And we can get rid of the grid if we like. And now what we'll do is we'll click on the find cumulative probability function here. And then we're going to specify that we want to find the area to the left of negative 2.01. So that's going to be our maximum value. We'll leave the min as negative infinity, and the max becomes negative 2.01. You can see here, right, that this blue area here that there is shown is the area below the normal distribution, the standard normal distribution, to the left of negative 2.01. And this area is 0.022. So this is the p-value. It's the area to the left of the standardized test statistic because we have a left tail test. Okay, so let's wrap this up. We found that the z-score was negative 2.01. This is the standardized test statistic. That was that. And then for part D, we're going to do the p-value, which we already did. So I'll just put it right here. So D, the p-value, that was the area to the left. That's the probability that Z is less than negative 2.01. And that area was 0.0, let's double check, 0.022. So we're at the last step now. It says make a decision. Well, alpha, the level of significance is 5%. This is the threshold that we use to make a determination about whether we're going to reject an hypothesis or fail to reject it. In this case, the p-value is less than alpha. So for the last part here, the p-value is less than alpha, right? 0.022 is less than 0.05, right? 2.2% is less than 5%. When the p-value is less than alpha, we always reject the null hypothesis, and therefore we're going to support the alternative hypothesis. So we're done with this problem. We are going to take a look at these hypotheses now. We're going to reject that the population proportion is 68%, and we're going to conclude that the population proportion is less than 68%. So we are basically supporting the alternative. We believe that the proportion of college students in Connecticut who think fake news is a problem for the democracy is less than the national rate. We are supporting the alternative hypothesis. We believe the proportion of college students in Connecticut who think fake news is a problem is less than the national rate. All right, guys, hope this helps. Make sure you work on these problems. And if you have any questions, of course, let me know.